Today's training is online training. We're doing an introduction to the system itself. We're doing an introduction to some basics of installation, operating procedures and methods of the system. And then we'll talk about some key settings. Then on Friday, this week, we have physical training in Joburg. And next week, we're going to be having physical training in Cape Town to actually come put the thing together, take it apart. The good news on this is the actual time it takes our teams now that have done a few installations already to put the boxes on the floor, to unpack them, to mount and connect and commission is about an hour, maybe just a little bit under an hour to do the whole thing. That excludes the installation of the PV modules, obviously, and that excludes the integration into the DB, especially if there's some changes required on the DB. But the system itself is incredibly fast. So what that means for you, less time spent doing it. And in fact, there's very little to go wrong as well. So can everybody see the screen? If you can't, please let me know. And we'll get going. So we're going to start with an introduction to the product. What is it? Well, the reason we call it a system is we're not just selling an individual component. It's a single phase hybrid inverter, a true hybrid inverter, paired with high voltage lithium ion batteries. Kutsa, you absolutely can get copies of the recording, no problem with that. So when you buy the kit, we have a single part number, and that part number comes with the hybrid inverter, comes with the batteries in the size that you've requested, comes with a battery management system that allows the inverter and the batteries to communicate seamlessly together. It includes all of the protection between the inverter and the storage, so you don't have to go out and add a whole lot of other stuff. It includes a single phase power meter with a CT. It includes your communications dongle that you use for Wi-Fi and Ethernet. And all of it comes with one part number. And really valuable for you is there's one accountable party. There's no point in this installation where somebody's going to say, oh, okay, but the battery's from this manufacturer and the battery management system is from this other manufacturer and the inverter's from this other manufacturer, and we're blaming this person, or we're blaming this person, or we're blaming this person. There's one phone call if something goes wrong, and we have the ability to fix, service, and or repair, or even replace all of it, or part of it. What does it do? Okay, so it's an incredibly flexible system. You'll see when I talk about the architecture in just a moment. So it's one system which, just like everybody else, converts PV energy from panels into usable energy. It's single phase, so 230 volts is the standard. It also stores energy, so it's a full storage system, either from PV or from grid, for really 4 key things. Number 1, during load shedding, which we know of in South Africa is really critical. Number 2, during peak times, so we can do load or peak shaving. Not so commonly used because we don't have a time of use tariff on residential yet, but that may come. And of course, for some clients, they maybe want to have a bigger demand than the supply that they have. So this will allow for that. To reduce grid use or reliance on grid during sunshine hours, which we call self-consumption. And in fact, we can do it after hours using self-consumption as well with the batteries. And then finally, where there is no grid at all, we can operate in microgrid operation, in other words, to form the grid itself. And then all of this displays on your phone, your laptop, your computer, a big screen in the middle of the office, wherever it happens to be, so that you've got free for life app to both view and control the system. So it's a complete system. Okay, so how does it do it? Well, there's your circuit diagram. End of the training, you can go home and we're done. No, I'm just kidding. When you look at that, that looks quite complicated. So what I'd like to do is just spend a few minutes actually breaking it down to explain the architecture, what makes it a little bit different, how it works, and then we can answer any questions. What I'd like to do is, if you have any questions as we're going through, just raise your hand. As soon as we get done with that little section or that sentence, then I'll stop. You can ask your question either in the chat, or you can unmute yourself and ask the question, and we'll answer it, because if you're thinking it, maybe somebody else is too. So how does it do it? How does this thing work? Well, there's our inverter. Everybody's aware that's the symbol for the AC side. This is the DC side. We have 4 real connection points, excluding the monitoring. So let's talk about that. The first point is coming from grid, right? We call this the grid port. This is where we would connect to the distribution board. We would have a feed coming from the DB and going into the inverter. We recommend a 10mm cable because we would also recommend a 63 amp breaker feeding it. Now, a lot of other inverters, may say, well, why do I need such a big one feeding it? Most inverters have a 40 amp or something breaker. Well, in our particular case, we can actually take up to 13 kVA through this line, right? 13 kVA, it's about 50 amps odd, something like that, right? So we put a 63 amp breaker in. The 10mm cable will allow us to import 13 kVA. You may say, well, I thought you said it's a 6 kVA inverter. Well, let's talk about that as well in a little bit. Okay, over here, we're also going to put our non-essential loads. So we would put things like geysers, pool pumps, ovens, things which you don't want to run on battery power. Okay, doesn't mean that you can't run them on battery power, but that you may not want to always run on battery power if your battery power is limited. Also, we have type 2 surge protection built in right here as well. This port allows for bi-directional energy flow. It is not a one-way port. It actually allows energy to flow from our inverter out into our loads here, as well as from grid into our loads and from grid into our inverter. And of course, we have the NRS compliance, so we meet all of the local standards here. The 6RS is also already on the City of Cape Town's approved list. So if you are Cape Town based, it's already good to go. You can just pop it on the wall, and any other places that are following City of Cape Town as well, you can use the system there too. Okay, so we call this our grid port or our grid connection. The second part is our PV panels. So we have 2 MPPTs on the inverter. Each MPPT is 600 volts DC and 30 amps, right? So 30 amps. So we could run 2 strings, in fact, of the new higher current modules up to 600 volts on the DC side. And that's fantastic because what that allows us to do is to put 13 kilowatt peak here as well. What? Now we've got a 6 kVA inverter, but we can put 13 kilowatt peak. Why would we want to do that? Okay, really, really amazing. There is a DC isolator included here as well. So on the side of the unit, you've got a DC isolator built in, which not only is an isolator, but it also has a lockout option, lockout tagout option. So from a safety perspective, you wouldn't have to add a LOTO on either. It's already there built in for you. And that one isolator isolates both strings or both MPPT inputs immediately. So you could be running however many strings once. And you've also got type 2 surge protection built in here too, right? So you've got type 2 SPD here on the AC side. You've got type 2 SPD here on the DC side, and you've got your isolator already built in there on the DC side. So from a compliance perspective, technically it's all there. My only recommendation would be during the installation, from a safety perspective, if you've got the panel sitting somewhere else, you may want to say, well, I actually want to put in an external box here where I can isolate the modules because they're not right next to the inverter. Of course, if they're right next to the inverter, it might be a different story. Again, that's a decision the competent person would make to say, well, technically we have protection, technically we have isolation. Do we want some next to the panels if it's not within arm's reach or not within view of the inverter itself? Okay, so that's our PV panel input. Then we've got our batteries, and our battery storage sits over here. On the battery side of things, we use a high voltage lithium ion system, and we say from 9.6 to 19.2 kilowatt hours of storage. Please note, this is usable energy. A lot of the other guys will say, well, we've got 12.8 kilowatt hours or 12 kilowatt hours, but you can only use 80% of it. Well, 12, if you can only use 80% of it, is actually 9.6. Every figure that we quote is always usable energy, not capacity. Okay, so please remember that, very, very important. When the customer says that I got a 10 kilowatt hour battery from somewhere else, or 2 5 kilowatt hour batteries, they're talking about 10 kilowatt hours, but they can only use 8 of that, for example. In this particular case, if you're talking about almost 10 kilowatt hours, you can use almost 10 kilowatt hours here. All the protection and the comms is included in the supply. Okay, and I'll show you a little bit more about that later, exactly what that looks like. So all you need to install between your batteries and your inverter, the only bit of kit you have to supply is 1 meter of red 6mm solar cable, 1 meter of black 6mm solar cable, and a 6mm earth, right? What's that, about 20, 40, 60 Rand? That's your total cost here. And in fact, this is actually just offcuts from your PV portion. Okay, so you've effectively got little or no extra cost to connect the two. Why is that possible? Well, because we're running a high voltage battery, so 6mm is absolutely perfect for what we're running. We're pulling 30 amps maximum. Okay, there's your batteries. And then finally, we've got our backup loads. So on the AC side, we've got our grid port. And next to that, we've got what we call our backup port, or our EPS, our emergency power supply port. And on this, you'll see I'm actually drawing, even though it's one output on the inverter, I've actually drawn it here with two separate outputs, just because that seems to be the most common way DBs are built in South Africa, where we put all of our plugs on earth leakage and a lot of the lights are not on earth leakage, so that if there is a trip or there's an issue here somewhere, at least you can still see what's happening in the daytime. Please remember, if you did choose to put a geyser or whatever else on your backup port, you would need to have that here on the one with the residual current detection, or the earth leakage as we call it. Okay, very important. This is not bidirectional. This is one way only. These loads are the loads that you will only run when grid fails. In other words, if I'm running my batteries and I have load shedding and my grid fails, I only want these loads to be able to be run by battery. Of course, if there's PV, they can run those too. That's just an extra bonus. But during a case of load shedding, my geyser can go off, my pool pumps can go off, my ovens can go off, all the rest of it can go off. All of these loads will be carried on my battery. So it's one direction only. We've got a 10 millisecond transfer time. In other words, when we do go through load shedding or a power failure, it's less than a full cycle. You may see a tiny flicker in the lights and everything takes over. In fact, we've already got into load shedding. Not during this meeting, during my last presentation, in the middle of the meeting, into load shedding. I don't even think I saw the lights flicker. Okay, it's 10 milliseconds. We do have a digital out option for load control, which we're not going to cover today. That we would cover in the more advanced setting. In fact, I think there are 4 DOs and 1 or 2 digital ins and digital outs. Analog in and out. And those we would control loads based on a variety of factors: time of day, battery state of charge. We can receive signals from outside, almost like a ripple relay, depending on which area, which country you're in. So please bear in mind that we can do those, even though we're not going to talk about those today. And then, so this is a 26 amp port. It's for only those loads that are needed during outages. We'll explain more about this side in a moment. We can push this up to 32 amps for about 10 seconds as well to deal with startup loads if you've got motors or something that needs a slightly higher induction load, for example, or startup support. But it's not going to last forever, right? I think that's 8.4 kVA on startup, otherwise generally 6 kVA. Okay. So this is our backup loads. Now, what makes this so different to what most people are used to? Well, most people are used to, let's compare this. Well, some people try to compare it to a 5 kVA or a 6 kVA or a 5.5 kVA. Let's rather compare it to an 8 kVA because it'll do the same job. So here we've got a bidirectional port from the grid. We have voltage sensor right here. So we detect voltage over here. So long as we have voltage here, in other words, so long as the grid is present and this voltage is in range, according to NRS 230 plus or minus 10%, this port remains active and bidirectional. So maybe we're producing 13 kilowatts of PV power. Let's use 10 kilowatts. Maybe we've got, I don't know, 10 kilowatts installed. We're producing 10 kilowatts just because it's an easy number to work with. At the same time, I can charge my batteries with up to 6 kVA. I can run 6 kVA loads here, and I could export up to 13 kVA there, all at the same time if I had enough power. right? So in a case where maybe I've got 10 kVA or 10 kilowatt peak here, or I'm producing 10 kilowatts, let's say my batteries are fully charged. It's reached 11 o'clock in the morning. My batteries are charged. My essential loads are pulling 4 kVA for whatever reason. I can still at the same time push 6 kVA back through here to all of my non-essential loads. So what that means is I'm not wasting power. I'm not curtailing power from my modules. I can run geysers, I can run ovens, I can have my pool pumps turn on, I can have all of these things fire up and run, so long as I've got voltage there. How do I do that and still not export power? Well, we have a current transformer, a CT, which is supplied in the box for you, and we install that right here at the grid connection. So we detect voltage at the inverter, and we detect current right at the grid. So long as this current is not exporting, I will continue to provide power here from PV, or even, if I set it that way, from my batteries. So let's say it's 7 o'clock at night. I could run my pool pump, if I wanted to, off my battery power. Well, why would I want to do that, you might say? Well, we've done the calculations, and it's about a Rand 66 per kilowatt hour to generate your own power and save it and use it again. So in self-consumption mode, I'm generating my power, I'm storing my power, and because these batteries are 6,000 cycles, right? The guarantee is 6,000 cycles on these batteries. We want to cycle them. We actually want to use it. It's better and cheaper for me to create my own energy, to store my own energy, and to use my own energy at a Rand 66 than it is to buy more energy from grid, even after hours, at 2 Rand 66 or 2 Rand 88 or whatever it is now. Okay, so it makes a lot of sense for us to cycle and to use the batteries. The fact that we're not exporting here is a setting. If City of Cape Town, City of Joburg, eThekwini, wherever, suddenly decides you're welcome to feed in, we can log in, we can change the setting. It'll take about 20 seconds, and we can enable, or we can remove the export limitation. And then the panels will never curtail. They'll just keep providing power as much as we can out there. Okay, of course, we're not going to sell back to the grid from the batteries. That's not going to make sense. But the modules, any excess power can sell back. All right. Do we have any questions on this architecture? It's a little bit different way of thinking when we compare to, what's in the market at the moment, but it's extremely, extremely powerful. We have 13 kilowatt peak. We have a 13 kVA feed here, and the 6 kVA really only applies to the power that we can produce from the backup loads, or for the backup loads. Okay, we can actually support more than that. So if we were pulling 6 kVA from the batteries, for example, and we were running 4 or 5 kVA here, we could, if we were producing more from our PV panels, also feed all of these. And we can do all of this at the same time. We can charge the batteries, we can run the backup loads, and we can run non-essential loads all at the same time. Good, so you have a question? Please go for it.
Yeah. I just want to get the mic off. All right. So in other words, your feedback can go back into the grid. Now, what do you do if your grid has got one of these meters that doesn't turn back? In other words, any essential or extra power that you are putting in the feed in is actually going to accumulate against your meter. So do you recommend that you can do a cutoff of some sort onto the grid? In other words, make the thing totally anonymous from the grid, as if you've got no, in the daytime, I'm talking when the PV is high enough, yes, so that you can run your non-essentials easily through that.
Absolutely. So you're 100% right. So right here, the CT sits here where my mouse is. Can you see my little cursor? Mm-hmm. So the CT goes there. It's a clamp-on CT. You don't even have to disconnect anything. It's you clamp the CT on, connect it into the meter. It feeds the data back, and it makes sure that when you set 0 export, or what we call it feed-in limitation. So we enable the feed-in limitation, and it will allow the PV or the batteries or the combination of both to continuously feed these non-essential loads, so long as this current remains flowing in this direction or 0.
Oh,
right.
Okay.
If the current was going to reverse and flow back the other way, we would then curtail.
All right, let me just clarify something here. So in other words, your CT should be behind your non-essential load points.
Exactly. I'm going to go
if it
to...
is in front of that, you're going to have a problem. Yeah,
exactly.
Okay,
you will have a problem. Now, so we're still looking at sort of the basic introductory training, but that's a great question, because imagine I had a load that I never, ever wanted to run on PV or batteries or anything like that. Okay,
yeah.
for whatever reason. Then I could actually move my CT to here, and I could put that particular load here. Because what it does is it looks at the current here, and the CT, at the moment we set 0 export, or what we call feed-in limitation, it will not export past that CT, even though everything on the load side, on the inverter side of that CT will be fed so long as our voltage is present. In other words, so long as grid is present, it will continue to feed them.
Okay.
So that's probably the most difficult concept which a lot of people have had, trying to compare. Well, I'm used to brand X. This is slightly different for me, but oh my gosh, it's amazing. Okay, it makes it incredibly flexible, and it means that you can still run the geyser. You know, a lot of people say, okay, well, my non-essentials are never going to be fed by solar. That's not true. They are absolutely going to be fed not only by solar power, but by battery power as well, in self-consumption mode, because it's cheaper to run them on your own power than it is to buy from the grid. Okay. That's the other thing which we are spending a lot of time explaining to end users, is these are no longer backup systems. The time for backup systems in South Africa is over. These are with 6,000 cycles and 10-year lifespans, not 3,000 cycle 10-year, but 6,000 cycle 10-year, like real 10-year cycles. They're operating systems in your home. In fact, this should be the primary energy source for your client's home, with backup from grid, as opposed to grid being primary with backup from your PV system. And the big difference there is the old method, the old backup system, was a sunk cost that people had to spend money, and it was exactly that. It was a cost, a grudge purchase. This is a return on investment, effectively. You're going to get a return on this. It is going to pay for itself, and the side benefit is that you have backup power and don't even know when it's load shedding. So again, we've moved away from that grudge, or I'm putting it in for load shedding, rather to this makes financial sense, plus cheers Eskom, I'm not interested. Okay, it's a great mindset shift, and it's a really great opportunity for people to do some great things. And of course, all the banks will finance these as well, so your clients don't have to lay out big capital in order to take advantage of the new systems. Okay. So let's talk about the wiring diagram. Now, this is for a TT system. Please, each home we've found in South Africa is a little bit different. Some homes are TNS. Some homes might be TNSC or TNC. So have a look at the home and just make sure that you're using the right installation. In a TNS, for example, we actually have a common earth as well. So we would remove this PE, and they would actually put in an earth neutral bridge to get it back. So what we found is, in some cases, depending on the home, the municipalities, it's their requirement to create that sort of star point, that earth point. But as soon as they go to load shedding, maybe the cables are damaged or there's an issue, and we lose that earth. Our recommendation is please put in an earth spike. If you're not doing it, start doing it, because it just gives them the option to go that way, or to really earth the system properly from a safety perspective. But I'm going to talk about the TT for now. We do supply in the manual all 3 wiring diagrams, by the way. Just please have a look on the site. What we've also found is we've got a same installer might do an identical installation on 2 separate homes, and the one we have to put an earth neutral bridge in, and the other one we have to take it out. And again, it really just depends on what's happening from the municipal connection side. Okay, so please just be aware and take a look. Here's the grid. Here's your main incomer. Here's the main meter. Now in South Africa, most commonly what happens is we actually have the main meter outside on the grid side. This is where the utility, whether it's Eskom or City Power or City of Cape Town or whoever. Then inside the home, we've got a breaker. This is where we would recommend that you connect your CT. Then all of your normal loads, or in other words, what we call the non-essential loads, will come off after that. We do recommend putting in an RCD here, but sometimes it's not necessary if you're feeding straight in. You might have your feed to your breaker, and this is where we recommended a 63 amp breaker here with a 10 mil cable going into your inverter. If you have a look, this is just a electrical diagram of what I've shown there. Okay, here's your inverter. Then on your backup port, we recommend having earth leakage there as well. In my drawing, I showed this being split with lights coming off, let's call it this way, without RCD. But on your RCD side, please, you just need to have protection for compliance so that when we are in a state of load shedding or grid disconnection, that your plugs that are on your backup port are still protected, right? That there is earthing in place there. Okay, so some key points, please. Separate neutrals, okay, for grid and for backup. So make sure that your loads are on separate neutrals. We've had a few cases where people have taken devices and they moved them from normal loads to backup loads or vice versa, and they've forgotten to swap the neutral along with it as well. And then it can cause an issue. So please just make sure that you keep the neutral separate. Please make sure that the PV panels and the batteries are also earthed. Okay, invert those, earth those to the chassis, and then that's straight to your earth spike. You can do that on the chassis, or I suppose you could actually do it in the DB as well. There are 2 earthing points on the chassis of the inverter supplied for you already. And then here, the meter power, when you power the backup, or sorry, when you provide the power to the single phase meter that's supplied, power it please from the grid side, not from the backup port. Because what it does is it uses the voltage reference to determine whether we're in a load shedding scenario or not. And if you power it from the backup side, it doesn't quite know, well, it's detecting voltage here as opposed to detecting loss of voltage from here. So please, when you power the meter up, just take that from the grid side. Any questions on this drawing as well? Okay, it's fairly straightforward. This is also supplied to you. We have it digitally. We do have it in the manuals as well. And we do have not just for TT, but we also have for TNS. Those are the 2 common ones that we see in South Africa on the homes, TNS and TT. Okay, inside the inverter, we normally, well, not inside the inverter, but inside the software, we normally run in one of 3 operating modes. There are actually 7 that are available for selection, but for South Africa, we only use 3. The most common is self-consumption mode. Self-consumption mode is very simple. The first thing we prioritize is solar power over everything else. The second thing is we will pull power from the battery to run any other loads on self-consumption until it reaches a reserve state of charge. Now, it's very important that we talk about the reserve state of charge. The SOC is not the battery's operating window. Remember, we always talk about 9.6 kilowatt hours or 12 or 16, whatever it is, as usable energy. So we can set the amount of usable energy. Normally, if we set it from 0 to 100%, and I'm going to use a 16 kilowatt hour system, for example, if I set my battery range from 0 to 100%, it means all 16 kilowatt hours are fully usable. There's no impact on warranty. They are designed to do that. In fact, the battery capacity is slightly higher, but because the BMS and the batteries talk directly to each other, we don't need to do any other settings on that. The entire commissioning process of the battery to the inverter is a total of 10 seconds. Does it automatically, does it by itself. You don't have to worry about it. And that available battery size, you can set yourself. You could, if you wanted to, set it from 5% to 95% for whatever reason if you wanted to, but 100% is fine. You also have the option to do a reserve state of charge. Now, what a reserve state of charge setting does, if I go back here, is even though if I use 16, we may have 16 kilowatt hours that we're allowed to use on the battery. You may put a reserve state of charge in, which could be, say, a 40% level. And what that would say is, so long as grid is present, in other words, so long as I'm detecting voltage here, I want my battery to cycle because it's cheaper for me to use my own energy than it is for me to buy more energy in from grid. However, I'm aware and I accept the fact that we've got load shedding happening at the moment. So don't go below 40% while grid is present. Of course, the moment grid falls away, in other words, the moment we lose voltage here, the inverter puts up an E10 error message, which basically just means loss of voltage, or they call it grid outage. This block, so we just set a number of 40%, but it could be whatever you set it at. This reserve state of charge block falls away, and the rest of the battery will function completely normally to carry all of our loads. Okay, some of the systems can't do that. Some of your higher end systems do that. We have reserve state of charge is what we call it. Okay, and that's for how much battery do we reserve for load shedding conditions. Okay, and then finally, grid will make up the difference. So PV first, then batteries down to our reserve state of charge setting while grid is present. Of course, when grid falls away, so does this limit. And then finally, grid makes up the difference. So that's the normal operating mode for systems, especially when there's PV installed. If there's no PV installed yet and you want to use it just as a backup system, or we want to use it to charge or discharge the batteries for whatever reason, maybe we're adding new batteries to the system and we want them to be at the same level, then we change it to compulsory mode. And compulsory mode, even though it's a digital setting, is actually like a physical switch. Really, what we're telling the system is ignore self-consumption mode. I'm just do exactly what I tell you. I'm either telling you to charge, to discharge, or to stop completely. And if I tell you to charge or discharge, I can set my kilowatt rating to whatever it needs to be. So, for example, yesterday I added another battery. I didn't even add the battery. I transferred one battery from one system on our CEO's house to another system on his house. So he's got two of them operating in parallel, each one with its own battery bank. And he wanted to move, instead of having 12.8 and 12.8, we wanted to switch it to 16 and 9.6 because the 1 dB works much harder than the other. In that particular case, we said, please charge, and I set the charge to 6 kVA. At that time, he's got 3.8 kilowatt peak on the one system, and it was charging at about 3.7 coming from PV modules, and it made up the rest. So I pulled another 2.3 from grid so that it charged the batteries at 6 kVA. We charged them both up to the same level, which was 99.8%, I think, at that point, and they both hit that point together. And then I was just quickly able to swap the batteries in about 15 minutes. Okay, this does not operate on a time setting, but rather it just does what you tell it to do for as long as it's there. Okay, so it's a compulsory mode that you can just override everything else on the system. And then finally, we have mini grid mode, or microgrid mode, as they call it. In here, we operate in off-grid mode. We do this when there is no grid connected. In other words, there is no Eskom. We're running on a farm or something like that. And the nice thing is it gives us the opportunity also to bring a generator in. So we can run a generator on that mains port as well. And we can use that to charge, discharge, backup, do whatever else we need. And we can run completely without it. What we do is we allow the inverter then to form the grid on both ports. Okay, so these are the three most common operating modes. You'll see these are not your everyday running settings. This is a selection for your client that says, how do I want to run my system? Do we have any questions on these? No. Okay. Let's see how we're doing. 9:40. Okay, I'm going to spend a few more minutes. If you guys are good for that, we'll just talk about some installation, what comes in the pack, what comes in the boxes, how it works. Then we'll take a break for a little bit. And then as soon as we come back from the break, we'll actually go through some of the settings of the system. So let's talk about installation. Okay, when you get your system, it's going to come in a few boxes. So in the first box, you get the inverter. It's the SH, which stands for SunGrow Hybrid, 6 kilowatt residential single phase. So that's that SH6RS. In the box, you get the hybrid inverter. You get a mounting bracket with the integrated spirit level. So literally, the guys pick it out of the box. They hold the mounting bracket against the wall, make sure it's level, draw a couple of circles, and then drill straight there. You don't even have to take out your own bolts or anything like that. All your bolts, the raw plugs, all the fastening screws, everything come in the box. So it's a 5-minute process to actually put the inverter up on the wall. I've seen people installing them at different heights. Our recommendation is try to get this little black square at eye height. That's normally what the clients want. It's the easiest way to do it. Some clients, though, say, look, put it up higher. Others want it lower. We leave that up to you. We're not specific around that. But in lieu of other information, the easiest way to do it, or the best way to do it, is just to have this black box at eye height. In the box as well, you get MC4 connectors for your 4 strings. So you'll see down there, you've got MC4 points coming in. That's 2 strings, 30 amps on each one, or 2 MPPTs, 30 amps per MPPT, so you could run multiple strings there if you wanted. You also get all of the lugs for your AC and earth cable, comes in the box. You don't even have to go and get others. You get bootlace ferrules. Oh, I didn't put what for here. That's for the connection of your comms cable, which comes in the battery box, but the bootlace ferrules are packaged here. So you don't even need those, but just make sure you've got something to clamp them with. You get the single phase power meter, comes with a CT. That's just a clip-on CT, so that you don't even have to disconnect any wiring to do that. The CT itself is also marked with a direction that says grid or load, so you even know which way to put it on. And if you get it wrong, to change it as a setting. You don't have to go back out to site again to turn it around. On the app, you just flip a switch, and it just says reverse meter connection. You reverse it, and it gives every value a negative value, so that saves you time and not having to go back. And there's a marked comms cable that comes with it as well. And then your YNET S communications dongle that plugs in over here. And that's Wi-Fi and an Ethernet port. So depending on what type of connection your client wants, the easiest and the majority of our clients just use Wi-Fi, connect straight to their home network, and then you can see everything on the cloud. Alternatively, some of our clients, especially if they've got sort of outdoor installations where they're putting it in the garage and the garage has very thick walls, they might want to run an Ethernet cable through and just plug it in directly. So all of this arrives in your inverter box. You don't have to go out and buy a whole lot of other stuff. You have to have your own tools, but you don't need to go out and buy, all the little pieces. You're never going to get stuck on site and the guy says, oh shit, I forgot to get some bolts, or oh, I don't have this, or I don't have that. Okay. The next box you get is the battery accessory box. And in the battery accessory box, you get 3 main things. Okay, there's some cables and things that come on top of it as well. But there's a base, and the base just looks like this. It's got a couple of handles. It weighs next to nothing. It comes with either little rubber feet to go on the bottom, or it comes with adjustable legs that you can raise it up off the floor. The majority of our clients use adjustable legs. This battery is IP55 rated, so it can get splashed. It's no issue. The guys want to raise it off the floor a little bit just in case somebody spills some water on the floor. And you'll see these handles just allow you to take it out of the box very easily. There's also an arrow, and it says on here back and front. So there's really no thought that's required whatsoever. The other thing that comes is the top section. Now, in the top section, you've got your battery management system built into it. So it's included in the top. You've also got your power on-off button and your charging indicator. So these are your lights. These are blue when the system is on. If you've got an error, this will go red. And your charging bar, as you're charging, it'll flash up, or if you're discharging, it'll flash down. And then when it's not charging or discharging, you will see the number of bars will show you your percentage. There's 10 here, so 100%, all 10 would be lit, 50%, 5 of the 10 would be lit. And then finally, your switchgear box. Now in here, you've got your DC breaker. You've also got your positive and negative connection points. Now, those come with SunClicks connectors. The reason they come with the SunClicks connectors is because your cable is the same as your PV cable, we don't want to mix it up. So you don't want to get it wrong and have your batteries plugged into your MPPTs, or vice versa. These are also supplied in the box, not just the 2 for here, but also the 2 that go on the other side of your cables as well. In fact, you get 4 of them, so for both sides of the cables, so that you just clip them in when you're ready. There's an earth point on top of here, obviously, that you just connect your 6mm earth plug. You've got a comms port on the top as well, and you get the battery comms cable, which comes in the box. So you don't need to add anything else to it. You slide this into the side, you connect all of your pieces up, and Bob's your uncle. I'll show you a picture of what that looks like in a moment. Then you will get a minimum of 3 boxes, okay, of your batteries. The batteries pop onto the base. So you pick them up with your handles and they just stack on top. You see how they connect in here? So this piece here connects into the bottom of your switchgear. This piece here connects into each battery. They are completely touch safe. So nobody's going to get hurt, injured. You don't have to worry about short circuiting or causing problems. You can touch that. You can run your hands over it. You can do anything you like there. And then you simply put your base down, stack battery number 1, battery number 2, battery number 3 in place. You slide your switchgear into the side. I think I've got a better view of that in just a moment. You connect your 4 cables, being your positive, your negative, your earth, and your comms cable, and then you pop your BMS on the top. It's a 10-minute process at max. It's so fast, so quick, so simple. The first time you do it, it takes a little bit of time because you're trying to figure out which cables go where. What a lot of the installers are doing at the moment is there's one guy as they're unpacking the boxes, the other guy's actually already putting the either the SunClicks connectors or the ferrule onto the earth cable. And as soon as they're done stacking, they plug these connections in, put the cables out the back, and they're done. Okay. There's also a cover plate. Now, if we install 3 batteries, you won't use the side cover plate. If we go more than that, in other words, if we go up to 6 batteries, on the top 3, you will clip the cover plates in, and those clip on the side here just to cover everything and make it look neat, where this piece, so your protection actually sits over here and is 3 batteries high. It's exactly 3 batteries high. So the reason we have the cover plate is your next 3 batteries would require that. We have a minimum of 3 that we stack, and we can go up to 6 in a single stack, and then we can parallel up to 4 stacks if you needed to. So to date, we've only had people go up to 2 stacks in parallel as the maximum, but you could go up to 4 stacks if you really wanted 80 kilowatt hours. I can only imagine that for somebody that would be running in a microgrid mode, maybe in a fairly remote area, that they would then want to go that big. Okay, so this is what it looks like. You would put your base down, you would drop on each one of your modules, put your top, well, then you slide your switchgear into the side, and that's what it looks like there in the side. Pop the top on, and then your cables will come out the back into trunking, and I normally use about 4 centimeter wide trunking. Some clients will use slightly bigger trunking if they want to. You could go up to 10 centimeter, 100 mil if you wanted to, but you're running what, 5-6 millimeter cables. So it's really not a lot. We've got some clients that bring the trunking up the side and then across under the inverter. In my home, it comes across and then goes up the middle to below the inverter. Okay, so it's a really fast process, really quick, really easy. And once your inverter's on the wall and your battery's up and done, your timing is less than an hour. It's probably about half an hour, maybe. You're probably about half an hour to get all of this done, and then the commissioning is the rest of it. So within an hour, you're done. Okay. Do we have any questions on this? Please, if you do have a question, feel free, just fire away.
Do you mind if I shoot at something?
No, go for it, please, by all means.
I'm coming in here as a newbie, so I might have some stupid questions.
No problem.
So I've done a lot of low voltage security for many years, and this kind of falls on the PV side and solar side as a bit of low voltage because we're going up to about what, 48 volt system, yeah?
No, this is a high voltage system. So each one of these cells is 66 volts. So if we run 6 of them, we're running about 500 volts on the DC side. So we do need to be careful. A lot of the other guys, even if they say they've got a high voltage system, they're only talking about like 52 volts. That's not the case. We run 30 amps.
Yeah.
Anywhere from about 200 to about 460 volts on the battery side. And on the PV side, we run at 600 volts. So it can be very dangerous if it's not done properly.
No, for sure. No, I'm happy with that. So I understand the diagrams and how it all fits together. So my question, I've got one last question, then I'll get out of your hair and I'll just listen in.
No, ask. By all means, ask away.
I was never formally qualified, even electronically, but I've got 20 years of experience. So yes. What is going on around the qualifications on solar? Because I know there's some serious mixed feelings at the moment. Feelings that only qualified electricians can do this. The guys that are doing the courses through the solar suppliers, their qualification has been said that it's not going to be worthy of doing the installations. Can you just give me some clarity on that, if you don't mind?
Yeah. So the I think the ECB, I think it was ECB. It was one of the electrical contractors board, or maybe one of the others, maybe the ECA, has put out a document which we can send to you. Daniel, maybe you can send it out to everybody as well a little bit later. That you are right. A qualified installation electrician has to issue the COC and has to be responsible for the work being done.
Yes.
What we see.
That doesn't mean anybody that it stops people from trying to do the work and train themselves to do the work. Am I right in saying that?
So remember, there's two different things. One is doing the work, and one is being responsible for the work that is done.
Yes.
So in these types of installations, the majority of work is actually mechanical, and most of the installation partners have got mechanical teams. So putting the panels up on the roof is a mechanical function, right? It's not actually an electrical function.
Yes.
Building these batteries is a mechanical function. Mounting the inverter to the wall is a mechanical function for the most part. Integrating into the DB and making sure that the cable sizes are correct, making sure that the joints on the cabling are correct. Those are electrical functions. Yeah. So you have to have an electrical qualified person on your team. However, most of the work is actually mechanical. And it sounds quite strange, but that's what we're actually finding. So a great way to do it is let's say an installation is taking 2 days, because even though this is only an hour, getting the panels up, if the DB has to be changed for whatever reason, it could take potentially 2 days. I would say most clients allow 2 days for a full installation, including panels. What will happen is on day one, purely mechanical team, the electrical guys won't even get there. Or if the company has two teams, the electrical team will be working on the DB and prepping the cabling, while the mechanical team is putting the rails on the roof, putting everything into its correct place, doing all the trunking, getting all of the non-electrical functions in place. So it's a long answer, but it hasn't given you the details you want.
What happens to the guys that have qualified through the different suppliers? What does that qualification mean for them?
Well, it's worth nothing. It's a supplier qualification. In our particular case, the supplier qualification is we're happy that you understand how our system works, and we're happy that you understand how to commission the system properly so that it does what it's supposed to do, that your clients and that you're understanding what it is that you're doing. From a legal perspective, right? In other words, if there's a fire, if something burns down, that person that was never qualified, that was never done anything, could not have issued a certificate of compliance.
Yes.
Right. So we've had guys that should know better, and I'm talking about big players that should absolutely know better, that have gone and put 20 millimeter, 25 millimeter cables on big systems where they should be having 70 square mils. We've had guys. So generally, I mean, the big thing for me is that people use wrong size cabling. Their cabling is going to get hot. It's going to start fires. They're going to cause all sorts of trouble. Or we've had other scenarios where we've gone in and we've said, guys, you've got safety risks. We actually identified a site that wasn't performing. We said, guys, you've got these massive safety risks. What are you doing? And the guy's like, oh, no, we're still busy on the site. We're still doing this. We're still doing that. Lo and behold, the guys get hit on the DC side because they had guys that were not qualified and didn't understand that 600 volts DC will kill you. Luckily, nobody died, but the guys got burnt, right? And luckily, 2 days before, we said, guys, you need to be careful. So they had already started making some adjustments. but it's 600 volts of DC, 1,000 volts of DC will kill somebody very, very quickly. So we have to be cautious. We're having a discussion with a client now where we limited their system's performance. Remotely, we went in and we turned their system down to half performance. And they said, why have you turned our system down? What's happening? Guys, your earthing isn't right. Your AC cabling isn't right. They'd sent us pictures of the system, and we could pick up from the pictures immediately that they hadn't done the job properly. And in those cases, my team are under instructions. We're generally very good, and so is Sungrow, by the way. Generally very good. If you come hand in hand and say, look, we screwed up, we did this, we did that, often they'll honor warranties, even though it may not be a warranty issue. In a case where safety is concerned, my team are under instruction. You cannot. You absolutely follow the letter of the law. Number one, I think Sungrow has liabilities on that. Number two, Hudeco, we're a listed company. We have governance that we have to follow as well. So when it comes to safety, unfortunately, that's the one thing that we're not negotiable on, because we can't have somebody dying, installer or end user, by the way. Our partners are really important to us. It takes a lot of effort. We walk a long road with our partners, and it's our responsibility to make sure they're safe. So your training is not worth anything if it's from a manufacturer legally. Okay. What it is worth is understanding the product and offering a better value service to your client. So that's where its value lies, right? This sort of training is about adding or managing expectation of yourself, of your client, understanding the product, understanding the capability, understanding how and where you can add value, and the difference between a return on investment and a grudge purchase. And I mean, it's little things like these battery cells aren't going to get stolen and used like a lot of the guys do. They put it in, and 2 weeks later they come back and their batteries have been stolen, and some guy's running his TV on it. They can't do that with this because the BMS works with everything. It doesn't look like a normal battery that people are going to go in and run. The 66-volt cell is not going to run a lot of the stuff that the criminals are going to be stealing. So it's advantages like that you'll learn on this sort of training. There are then 2 other courses which are valuable, which are not electrical courses, but one is the PV Green Card, which is supported by Sapphire, and the other one is PQRS, which is supported by a host of other things. And those are generic solar training courses and certificates which get given out. Again, they are not legal qualifications. However, they are required. So if you look at Standard Bank's Power Pulse program, for example, one of their requirements is you must have completed your PV Green Card. The reason those are good is they take non-electricians and they teach them all about what is required to do an installation, and not just the electrical side, but getting on the roof. What do the roofing structures look like? What are some of the design principles? I haven't even covered what is an MPPT here. That's generally expected that somebody would have known what that is. What happens if we have shading across some of the panels and there's a different MPPT to that? Is the other MPPT affected? So it's a nice course. It's a hands-on approach. Some people have done amazingly well with the PV Green Card. I also know other people that they've earned their PV Green Card, but there's no way in hell I would ever allow them near a site. So it depends on the person. Now, with 20 years experience, you may be able to get something called RPL, which is recognition of prior learning.
Yeah.
However, that's not within a supplier or a manufacturer's hands. That would come down to the ECA or the ECB. Okay. So a very long answer to your question, Jason. I hope it's okay.
No, perfect. We sit. So I'm formally qualified as an assessor and a moderator in the electronics industry.
Yep.
And we get a lot of questions because the systems, everybody's starting to kind of cross-pollinate.
Yes.
Guys are wanting solar, and they want security, and they want stuff on regulators and batteries and solar panels. And I think there's a bit of a disconnect still because the guys are still trying to figure out how the one works with the other. But you do have guys that have got very good electrical knowledge. So whether it's self-taught or book taught or not formally qualified, but these guys are doing the work. And I can tell you, being in the electronics side, I've had guys that have got no formal qualification that have done better installations than guys with formal qualifications. Yeah. So let's say, for argument's sake, there's a guy that has really gone out of his way to teach himself A to Z, and he does the installation. does that allow him to still get somebody to come and sign it off, as in the case of a COC? So,
Well,
because many of the guys that are
sure.
signing off, their workers are not formally qualified, but they've been taught by him how to do it. So it's kind of the same thing. So I'm asking, so I think you understand what I'm asking. He does the work, he knows what he's doing, he mounts it properly, he wires it properly, he lugs it properly, right cable, but he can still then just have it signed off, right?
Well, there needs to be an accountable, qualified person to sign it off and issue the COC. I think what we'll do, Daniel, is we'll just send that out. We'll send the document out that explains it clearly. I can't comment on somebody doing the work versus somebody else signing it off. I think the intention is that a qualified person should do the work. I think in practice that's probably not what's happening, because you can't have all the qualified people. Everybody on site cannot be a qualified person. I mean, even on a normal electrical installation, you have one qualified person and then like 3 or 4 other people doing the work. I mean, even if you're talking about a huge big building through a large EPC, you know, that's what happens. But
I can talk out of
sure,
experience that the guys on site, out of 99.9% of the times, are not the qualified guy.
Yeah,
he comes right at the end, and that's just how it works in Africa, I think.
Yeah, but for sure, you have to issue a COC, and well, certainly for our systems, right?
Yeah, absolutely.
For any of our partners, a COC has to be issued by a competent person, and that person is liable.
But that competent person will do dot all the I's and cross all the T's, surely.
Exactly. And normally they will be the person that comes in as a team leader. They will come in and they will actually do the final checks, the
due diligence,
sort of system warranty registration, the commissioning, and the handover.
Awesome. That answers.
Okay.
Thanks, cool.
Good. So thanks. Good question. We're going to go to break in a moment. Just a quick comparison. So you said, what are some of the differences between our system and, let's say, more common competitor at 5 kilowatt and 8 kilowatt hybrid? So the first thing, well, let's actually go. So the first thing is the voltage share. A lot of the other guys, even though they might call it a high voltage system, it's actually not. It's higher than 48, but it's not high voltage, right? In our case, we use a 400, well, let's say up to 460 volts, 500 volts, let's call it, as on the battery side. The advantage here is we can use a 6mm cable. We don't have to go and buy 25mm cables. So you don't have to go and buy that huge, massive, big DC box in the middle, and what's about $8,000 when you put all the protection in and the big cables and ugly looking and big trunking and all the rest of it. Okay. The second thing is our maximum DC input power. So in other words, how many panels can we put on? On ours, 13 kilowatt peak. Here, about 6.5 on the 5 and 8.8. That's the maximum that can be put on. Okay. Our strings can go up to 600 volts versus 500 volts. So in other words, we can run longer strings. And the MPPT voltage range, look at this, from 40 to 560 versus 150 to 425. What this means for your customer is you start producing power earlier on in the day and you stop producing later on in the day. You've got a much wider window. Our current customers are seeing about 4.8 kilowatt hours of production per kilowatt peak installed. Okay, what that means is it's money in your pocket, right? For every kilowatt hour you produce, it's money saved. So the return on investment from this is fantastic. Our clients are also, in general, oversizing their PV arrays, because a lot of our installers are still used to using old systems before they converted across. And so they would say, okay, well, you need a 6 kilowatt peak system, and then the batteries are full way earlier, when in fact they could have got away with a 5 kilowatt peak system. So the capital cost can also be lowered, because this is so good. I've never seen a system, and I mean, I've been in this business since 2009, and I've never seen a system that produces as much energy. The next thing is your startup input voltage, 50 volts. We're starting at 6 a.m. up in Joburg at the moment, whereas here you might start up a little bit later. Also on cloudy days, we're producing right from very, very early. Okay. Maximum AC input power. So not only do we have the DC input power, but look how much we can bring in. So we can run all of our backup loads. We can charge our batteries. We can run absolutely everything, 13 kVA on the input. Here, in order to do that, you would actually need to buy and install 2 systems. Okay, so that's just to run, say, 6 kVA on your loads, plus charge your batteries. Even here on an 8 kilowatt hybrid, right? you couldn't charge your batteries properly plus run all of your backup loads, right? Let's say everyone says, well, I want a geyser on it. Well, it's not going to happen, guys. Whereas here, it's not even we don't even bat our eyelids. Also, this system is fanless, right? Natural cooling. So no fan here, absolutely quiet. It looks fantastic. You could install it inside if you wanted to. Whereas here, I don't know if you've ever heard the fan on this 8 kilowatt unit. It's pretty loud. You actually have to try and install this far away from anything, or it's disruptive when it's charging or running. Okay, from accessories included, in fact, all of these now is fairly similar. So Wi-Fi dongle, free lifetime access here, you get it as well. And configuration, it used to be local keypad, but now this has actually been updated as well. So there's mobile apps on these too as well. Okay, so we take a look at how these look. You can see across the board some absolute huge benefits. Okay, much better system. We're comparing a tier 1 manufacturer with a high-end new modern system to a good system, a robust system, but nowhere near the return on investment and nowhere near the power coming out of this. Okay, so it gives you a great opportunity to compete against the competitors. By the way, we have the Black Friday special. This inverter, 20,500 Rand. I think it's normally about 23 or 24, maybe 25, right? So in fact, it's priced around here. At the moment, this Black Friday special is actually going to drop it down lower than that, and you're getting as much power, but with a lot more flexibility as here. Okay, so it's an absolute no-brainer. The big cost, in fact, is in the batteries, but because we're getting 6,000 cycles out of the battery, it's a huge number. If you look at some of the other local 4,000 cycles, so they call it 10 years, but 4,000 cycles is not 10 years at 1.6 a day. It's a hell of a lot less than that. In our particular case, even if we had 1.6 cycles a day, right? So 1.6 cycles a day for 6,000 cycles to 100% DOD is 10 years. Okay, so it's a proper, real guarantee. Again, backed by a listed company, and the Sungrow itself is the most bankable inverter company globally. It's just their 4th year in a row that they've received 100% bankability rating. It's the only company ever to have done that in the PV space. Quickly review. And then we'll get into some of the settings as we go to the intermediate stage. So the basic part we've done. Now we're going to get a little bit more complex. So if we remember the product offering, to summarize on the inverter side, 6 kVA just on the backup loads. Obviously, we know it's actually 13 kilowatt peak and 13 kVA on the other port. 600 volts DC, really big MPP voltage range, silent, powerful. It's incredibly efficient. 13 kilowatt peak, and which I haven't mentioned yet, but we could parallel up to 3 units if we needed to. To date, we have very few clients that do. The majority of our clients actually only go for a single system. We've got maybe 10 clients only that have gone for multiple systems at once, and these are really guys that are running really big houses. There's a doctor in Copperleaf, couple of houses in Sandhurst, and Westcliff. Other than that, most of the guys are just on a single system. I have a single system, by the way. I have a 4-bedroom house in Bryanston, and I don't see any issues with it whatsoever. Storage side, it's a high voltage lithium iron phosphate. This is a 9.6 kilowatt hour unit. You can see there's 3 batteries here. This is the largest single battery that we can run on the single phase unit, 1, 2, 3, 4, 5, 6, which is 19.2 kilowatt hours. This is 9.6 kilowatt hours usable. We could put up to 4 in parallel. There is a 10 kVA 3-phase unit available, which can be paralleled up to 5. I say available. It exists, but it's not available. In fact, there's just no stock globally whatsoever. So we are waiting for the updated version of that to number 1 come out and be released, and number 2 to be available to us. 30 amps is the continuous charge or discharge from the battery side, and we can actually go 42 amps for 10 seconds off the batteries. IP55 rated, whereas the inverter itself is IP65 rated, so we can actually install this outside. Modules, we're not talking about modules today, but we do have modules in our range. This says 390. We've actually, now that's increased to 400. So we are agents for Jinko. and we represent obviously the P-type modules, which everybody's used to, but there's also the new Neo range, which is the new N-type modules that you're going to start seeing coming out in the market more and more. Those are the negatively charged as opposed to the P positively charged modules. And you'll start hearing people start talking about TopCon as opposed to the MonoPerk. So the positively charged ones are MonoPerk, the negatively charged are TopCon, and we have everything from a 400-watt N-type module all the way up through to, I think we've got 550 watts in the P-type, which is your MonoPerk available as well. Big difference is the P-types generally in the market, 12-year mechanical, 25-year linear power warranty. The new N-types go to a 15-year mechanical, 30-year linear warranty, and the degradation goes from about 0.55% per year down to about 0.44% per year. So in fact, the module's performance is better over time, and we're happy to talk much more about that with you. What a lot of our clients do is they like a kit. So effectively you would say, okay, I want this plus my batteries plus the X number of panels. We bundle it all together in a kit for you and ready to go. We can ship all around the country as well. We've got about 153 different branches. So we can ship, depending on the size, by the way, if it's sort of 1 or 2 systems, we would generally ship to our nearest branch. If it's, Daniel, just remind me, is it 10 or more, hey? We'll ship directly to your site.
Yeah, 10 or more.
Okay, so if you buy 10 or more systems at a time, then we'll ship straight to site. We've got some clients that they say, look, I do 5 a month, so every second month I'm going to buy 10 systems. With approved credit, we do offer terms as well. So whether you take it on the 3rd of the month or the 29th of the month, you end up only paying, obviously apart from the deposit, you end up paying only at the end of the next month if you've got the approved credit in place. So that makes it nice and easy to manage your cash flow. Okay, so let's talk about, oh, my spelling is atrocious. That should be settings. I'll fix that. Daniel, please just remind me to fix that right afterwards.
Yes, please. James, do you want me to quickly do a bit of a selling point feature system for the cars?
Yeah,
would you like to do it at the end? I think
let's do it at the end. Let's get through some of the features first, through some of the settings first, just in case there's any questions, and then we can talk about the features right after that.
Awesome.
Okay, great. So, gents, I'm going to quickly pull up. There we go. Can you see that? Everyone can see my screen, right?
Yes, no problem.
Great. So we already spoke about this, the summary of the key operating modes, which we covered in the basic training. So we spoke about self-consumption mode, compulsory mode, and mini-grid mode. Then when you first turn the inverter on, as you fire it up for commissioning, the very first thing it asks you to do is to do something called initial grid settings. So when you turn it on, we always turn on the DC first. So you turn on your modules, your battery. You'll wait for about 10 seconds, and then you'll hear a click as the battery relay closes. And that means the commissioning on the battery is done. You don't have to worry about anything else. Then on the inverter, you log in with your local access, and we'll teach you how to do this more in the in-person training. The very first thing it comes up is it says initial grid settings. So we select South Africa. We select NRS, which is our requirement for South Africa to comply. There's the feed-in limitation. We enable that. Now, in fact, on the new firmware version, we just put 0 and 0, but I think there might still be some versions with version 25 or 26 on the firmware, in which case, as you enable feed-in limitation, you put 0.01 under how much energy we are allowed to export and 0.1% as a total of your installed PV power. As soon as you put this in, the system reads them as 0. I think there was an earlier firmware version, I can't remember which one it was, where if you put 0, it actually gave you a divide by 0 error. So they've sorted that out, but just in case anyone comes through. So we put 0.01 and 0.1, and the system just reads that as 0, and we don't export. We then have backup mode. So we click enable backup mode. And the moment we enable the backup mode, that basically tells the system, because it's a true hybrid, you can actually install it without batteries. But because it's a true hybrid, as soon as you say backup mode, it says, okay, start using the batteries. Recognize and realize that there are batteries there. Now, this reserve state of charge actually doesn't come on for initial grid settings, but I put it here just to show you that the moment you do, we'll go into some of the settings later. And we would normally recommend start at like 35%, 30%, 40%, something like that, which is just how much energy we're going to reserve for load shedding only. Okay, so it'll allow the batteries to cycle fully in self-consumption mode as much as we like, but it'll always keep at least that much so that you haven't used all your energy all night long and saved all the money, but then you get struck with load shedding and then your client phones you because they're angry because you've depleted the batteries. Okay, so once you do that, then the little blue light on the front of the inverter will go from flashing, it'll turn solid, it'll wait for 60 seconds. The reason it'll wait for 60 seconds is because that's what's required by our national standard. And then you'll hear the relay click a few times as well, and then it'll come live, right? In other words, then it'll take over the load. Okay. In the menu system, the client, in other words, the end user, has access to these common parameter settings. So the next few things that we're going to go over are the things that the client can control themselves. You'll see I've got a lot of things in black. I've also got some things in blue. The things that are in blue are the settings which we're going to change when we're doing commissioning, or at least look at and potentially change if they're not there from default. All the rest are the default settings, which by selecting NRS will automatically take you to those, but it's good just to know that you can change them if you need to. So the first one is on the menu, it says system. There we can start, stop, and it's basically the way we can turn the inverter on or off from the AC side. Obviously, sometimes people just shut down the breakers and shut down the inverters and shut down the batteries and whatever else, and that's okay. But the best way to do it, just like you would shut down your computer instead of just suddenly turning it off, is you would actually go shut down. What it does is when you turn it back on again, it actually goes through the startup routine properly and just sort of resets all the cache information. The next one is protection parameters. We'll cover this a little bit more. This is really talking about low voltage, high voltage, frequency. We set all these parameters in the advanced settings, but the client can choose what level, 1, 2, 3, 4, or 5. Basically, it allows things like high voltage ride through, low voltage ride through, a whole bunch of other stuff. And third is normal. It allows us, even though the national standard says voltage can go up to 253, in other words, range from 195 to 253, it allows us to ride through as high as 276 volts for a short amount of time if there's a spike in the voltage, which during load shedding is happening quite often as they bring transformers up and down across the city. We're seeing voltage spikes happening. The next one is connection time and reconnection time. So this is how long it takes to go from standby to running mode. And this one is how long it takes to return from a fault to running mode. Effectively, NRS tells us we have to have 60 seconds here. Okay, that's a minimum. Here, you can actually set this down to 10 seconds is the shortest time. Backup mode, we did this in the initial setting, but if it's not, you can turn it on and off here. So that should be enabled. And your reserve state of charge should be set at whatever you want it to be. The clients, the end users, in other words, the homeowner can control this, and this allows them to say, well, we know we're going into stage 5 load shedding. I want to set my reserve state of charge to 50%, or look, we haven't had load shedding for months now. I'm going to drop it all the way down to 10%, 15%, whatever it is, 20% of my batteries so that I can cycle and get the best return on investment from me. The next option or the next category is instead of power control, it's energy management. And this allows us here to do weekday discharge times. So in other words, this allows the batteries to discharge during self-consumption mode. For South Africa, on residential, we do not have time of use tariff. So in other words, it pays us to use our energy first from the batteries. If we had a time of use tariff, in other words, the cost of electricity was more between, say, 5 and 8 p.m. or 8 a.m., it doesn't really matter, whatever time. We could change this to say, don't cycle my battery. I want you to save my battery, and I only want you to use it during peak times. Okay, it's nice and flexible. For now, we just leave this 24 hours a day. If the tariff structure changes, know that you can change this very easily. So we call that the weekday discharge or charge. And we can also have for weekend, same. We can turn it on and off if we want it to be different for weekday or weekend. That's discharging, in other words, using the battery power during certain times. Of course, if there's load shedding, the battery will immediately kick over. By the way, this is for self-consumption mode. So if there was load shedding, it would discharge already. Forced charging is exactly the opposite. Forced charging says, now unlike compulsory mode, which just tells it to do it, forced charging says, during this window, whatever time it is, I want you to check the state of charge on my batteries. If the state of charge on the batteries is below what you're setting for me, I want you to charge it either from solar or from grid. Okay, in fact, it's actually from grid. So if we turn forced charge on, we can say, do you want it weekdays? Do you want it every day? When do you want it? What time should I start? What time should I end? And what percentage should I go to? An example of this might be, every day from 7 o'clock to 8 o'clock, I want you to check to see if my batteries are at 80%. If they're not at 80%, top them up to 80%. Okay, and keep them at a minimum of 80% until the end of that time, until whatever time I said, 8 p.m. Okay, where this might be used is maybe it's rainy for whatever reason, and we're expecting rain for 2 weeks, and we're worried that the solar power won't have my batteries at the right level, but we do know that we've got load shedding coming later. So every day, I just want you to top up my batteries. Okay, we call that forced charging, and we can do that twice a day. So we could have a morning and an evening, or we could have an evening and a midnight, right? We've got some clients that say, well, I don't want to put in a huge battery system, and I run a lot of loads at night for security. So I want you to do one at 6 p.m. Well, let's call it from 5 to 7, something like that. And then I also want another one from 11 to 1 in the morning, just in case, so that I know if I've got load shedding at 3 in the morning, my security lights and my electric fence and everything is still going to stay up. So that would be a great example of where we would use forced charging. And then this digital out configuration, again, I'm not going to discuss this in today's training. This is more of the advanced settings where we're controlling other things based on whether a state of charge or a time or something else. Okay, so these are the things that your client can control. However, what you can control, you get advanced settings as the installer. There's a lot more things. There's about 180 different parameters, 181 different parameters that we can control. Many of which I would say don't worry about to start. We will support you as you start doing installations to understand what each one of these things is and does and how we change it and how we affect it. But there are some key ones that you should know about that will support your client. Okay, so on the protection parameters, you see how many different things we can look at here. So 10-minute over voltage protection, low voltage ride through, high voltage ride through, grid imbalance. Are we actually detecting the grid before detection? Here's this grid connection time is 60 seconds from NRS. This active power rising gradient, how fast do we want our panels to respond so that once the system starts up, do we want them to come up slowly or do we want them to come up faster? This eye leak stuff here. This is basically earth leakage. So this is your current leakage. We can control 30, 60 milliamps, 150 milliamps. 300 is the normal value that we use for South Africa. Are we doing a self-check on current? You know, are we doing active island detection or passive island detection? So all of these things are options. It's an incredibly powerful system, and we have a lot of control over a lot of things. Okay. The next one is power control. So you see in the protection, most of the stuff we've already got set. You may want to change active power rising gradient. So this is how fast do our panels respond. Everything else you can just leave. Once we get to power control, there's some things which you want to check. So, I mean, we can look here, the different ways of MPPT scanning, arc fault detection. What is important is auto fault recovery. Please make sure that that's enabled. So in other words, if there is a fault, the system will recover itself. Often, you know, if there's a grid over voltage, if there's a comms error from the BMS, if there's a power outage, something like that, you know, then the system will recover by itself. If you disable that, whenever there's a system error, the system will wait for you to come and have a look, say what's going on here. Okay. It's really for safety, just to say, do we want to do it? And in fact, most of the time for a residential system, we wouldn't have it. Where guys would really use auto fault recovery off is on a big utility scale plant, you know, if there's a, I don't know, earthing issue. Okay. The next thing is our active power gradient control. When you log in there, the standard is 10% per minute. So in other words, the rising and declining gradient of our PV production is rated at 10% per minute. So in other words, if somebody's geyser kicks in and it goes from having a 1 kilowatt load suddenly to a 4 kilowatt load, the panels will only increase at 10% per minute to cover that. So let's change that. I recommend you change that to 500 or 600. So within what, let's say half a minute, it will pick up and it'll cover that load. In the meanwhile, it'll pull that power from grid just to cover that initial spike. And you may say, well, why doesn't it just kick on immediately? The concept is the same as, you know, the guy in the Porsche or the M3. As the traffic light goes green, they slam on the accelerator, they spin their tires, they race to the next traffic light, slam on the lights or slam on the brakes, and they've got to service it very often, and the tires don't last so long. On a solar system, we see the same thing with IGBTs. So we don't want to whack the system up, down all the time. So we program it for as long a life as possible with as slow and as easy, smooth curves across the board. However, that's probably not the best way to go. So we recommend turning it up from 10% per minute to 100, 200, 500. We can go all the way to 6,000% per minute, right? But then you're that guy in the M3 smashing your accelerator and your brakes. So we don't recommend that. Okay, 500 is normally a good value. Okay. This active power limit that we spoke about, we can limit the production from the system to meet a certain level. I've only ever done this once, and again, it was to protect cable sizes. If an installer has installed the wrong cable size, we can manage this, and we would just turn down and say, listen, you're not safe at the moment. You're trying to produce, well, in this case, it would be you're trying to produce, say, 10 kilowatts, but your system, your cable can only handle 5 kilowatts safely, right? So that's where and how we could limit that. Install PV power, this you would have to set every single time. The feed-in limitation, we set this during the initial configuration, but you can go in and change this anytime. It's a setting. So if, for example, suddenly the site gets registered and everyone's happy for you to feed in, you just come here and instead of enable, you would just close the feed-in limitation, and then it would just start exporting back to grid. Or, like in Australia, for example, they say, well, you can feed in, but you can only feed in 3 kilowatts. Okay, no problem. We can then just put 3 kilowatts here instead of 0. Okay, or we could do it as a ratio. In other words, if you're producing 5 kilowatts of PV, let's say we used 50%, we could say 50%, it would only allow us to feed in 2.5 kilowatts. This is back to grid, by the way. So we call this zero export. So zero export is generally the term we use in South Africa, because for us, it's either on or off. But in other areas in the world, you can actually feed in a certain kilowatt amount. That's why they call it limitation on the feed-in. Then we've got a whole lot of settings about power regulation, over voltage, over frequency, under frequency, and so on. Grounding detection, please close this. For South Africa, we are very strict and also very good on the amount of earth leakage devices that get put into houses. The unit itself has the ability to test for earth leakage, which we call grounding detection. The problem is sometimes it'll pick it up and it'll clash with the earth leakage we've got. So make sure you close this grounding detection. Otherwise, you might see an error 304 and the batteries won't connect. It'll say, I've got an issue here. The moment you close that, everything's fine, no issues at all. Meter communication detection. This is where we would communicate with the CT or with the meter that we provide. And that's what we use to detect for zero export. If you turn that off, the system will go, it will stop exporting on the grid port. Okay, the moment you turn that off, it'll stop exporting and it will act really just only as a backup system. Okay, so make sure that you enable that if you want to be able to run your non-essential loads. Your forced AC bypass, instead of running through the inverter, so in other words, as your energy comes in from grid, we don't have to convert and then invert back again to run your loads. Once we're happy that everything's fine, we can actually close the bypass relay, and then all of your loads will just run off grid power under those situations. That's the 10 millisecond relay there. Okay, so we enable that forced AC bypass. Number 29 here, this is the reverse meter connection. So this is really where if you have installed the CTs backwards, you don't have to go to site. You just click enable and it'll turn the meter around digitally for you. Okay, very easy. Import power limit, as opposed to the other export power limit that we said earlier. This is again to protect if cables are too small, or if you want to do demand management. So maybe your client says, well, if I'm allowed to import 6 kilowatts. If I go over that at all, I'm charged an extra fee. You can set a limit to the amount of energy that you import here. Okay, the default is 13, so it's that 13 kVA, and that's protected by a 63 amp breaker on a 10 mil cable. If you've got any questions on any of these settings, by the way, please ask me. The first time you do the installation, we're going to go through all of these as well, and you'll actually see them pop up on the menu list. Okay, so that's power control. The next one is our energy management, and this here is where we choose our operating mode. So I spoke to you that there are multiple modes available. For South Africa, we use self-consumption, we use compulsory, or we use microgrid system. So only those three we would use. Once you select self-consumption, it'll bring up a new menu that says charging, discharging, and how much power you want to do that with. Okay, so this is where you would do that under energy management parameters. And then we've got external EMS heartbeat. This is like Ripple Relay. So I think that's actually designed for the Australian market, I believe, where we can actually receive a heartbeat from an external energy management system that says, okay, things are still okay. And as long as things are okay, we keep doing our same thing. If that heartbeat changes, it'll change its mode of operation. And then battery first. Here we can say, well, we want to charge the battery first as opposed to running loads first from PV. So you can set your priority there. And then finally, your battery parameters. So this is different to your state of charge. If you remember, I said that we've got two different options. The one is your upper limit, and the other one is your lower limit. So effectively, this is how much energy you can pull from your batteries. You can change this to 0% if you want to. And that would give you the 9.6 kilowatt hours or 16 kilowatt hours or 19.2, whatever, usable, which is a different value to that reserve state of charge. This applies at all times when there is no grid present. The reserve state of charge is a limit that comes in between these two limits that says the amount of energy that you need to save for load shedding scenarios. Okay, and those are the parameters. You might be sitting there saying, oh my gosh, there's a lot there. I'm never going to remember all of this. That's fine. You're not supposed to remember all of this right off the bat. We will share this. You will be able to go through all of this. We will support you on those installations until you're happy and you know exactly what settings need to be. And in fact, most of them are actually already in place as soon as you set South Africa as your country. So these are the default settings, but it's just to show you that you can change them, you can manage them. At my own home, for example, my voltage often pushes up to 258 volts. So in other words, the national standard says 253 is the maximum. The moment we go above 253 volts, the inverter actually disconnects because it's required to. It's not a fault with the inverter. It's an NRS setting. So we've actually had to change my not only my protection level, but we've actually changed my ride through with my high voltage ride through switch, so that mine actually only kicks in at 260 volts now. So when I go up to 258 volts, the system says, well, it's fine. So my own home system is not NRS compliant, but that's on the back of the utility not being compliant themselves. So if they come and they give me a hard time and they say you're no longer compliant, my response to them is very simply, look, yours is not compliant and you haven't been compliant for 4 months. Sort yours out and I can sort mine out. Okay. Of course, we can't give end users access to do this, because they could then take systems that are compliant out of compliance, and you as the installer or provider would be blamed for installing a non-compliant system. Great. Thank you, everybody. Have a fantastic morning. Daniel, thanks for hosting, and cheers, gents.
Thank you, guys.
Thanks. Cheers.
Bye.
Bye.
Thank you, guys. Bye-bye.